that for vector p equals I plus j plus k and vector q equals minus I minus j minus k, show that in this special case vector p cross q is equal to vector q cross vector p. So we need to first, so this is vector p, it is I plus j plus k, and then vector q is minus I minus j minus k. So we need to find vector p cross vector q. In that special case, so let's first find vector p cross vector q. So in Cartesian form, this is I plus j, I, j, and then k, and p is 1, 1, 1, and then q is minus 1, minus 1, minus 1. So p, vector p cross vector q is equal to I, this is plus, minus, plus. So I, then you cancel the row and column and write the 2 by 2 matrix left. So this is 1, 1, minus 1, minus 1. Then minus j, and you cancel the row and column of j. The 2 by 2 matrix left is 1, 1. Then minus 1, minus 1. Then plus k. The 2 by 2 matrix that is left is 1, 1, minus 1, minus 1. So this is equal to I, and then 1 times minus 1, then minus 1 times minus 1, then minus j, 1 times minus 1, minus 1 times minus 1, then plus k, which is 1 times minus 1 minus 1 times minus 1. So this is equal to, so let me continue from here. So you see that 1 times minus 1, so let me first bring I. 1 times minus 1 is minus 1. Then minus 1 times minus 1 is plus 1. Minus j. 1 times minus 1 is minus 1. And then minus 1 times minus 1 is plus 1. 1 times minus 1 is minus 1. Minus 1 times minus 1 is plus 1. So this is equal to 0i, because minus 1 plus 1 is 0. Minus 1 plus 1, so it becomes 0i minus 0j plus 0k. So all of this is equal to 0. That is p cross q. Now let's find vector q cross vector p. And this is equal to, so I, j, k. This is the unit vector. And then vector q is minus I, minus j, and minus k. Vector p is I, j, and k. So this is equal to I. You cross out the row and column and write the 2 by 2 matrix. And this is minus 1, minus 1, 1, 1. Then minus j, because we are using plus, minus, plus. Then you cross out the row and then the column, which is minus 1, minus 1, 1, 1. Then plus k, the unit vector k. Then you cross out the row and column. You left with minus 1, minus 1, then 1, 1. So this is equal to I, then minus 1 times 1, because we are finding the determinant of these 2 by, then minus 1 times minus 1, then minus j, to bracket, minus 1 times 1, then minus 1 times minus 1, then plus k, into bracket, minus 1 times 1, then minus 1 times minus 1. So this is equal to I. Minus 1 times 1 is minus 1. Minus 1 times minus 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 1 times minus 1 is plus 1. Then minus j. Minus 1 times 1 is minus 1. Minus 1 times minus 1 is plus 1. Then plus k. Minus 1 times 1 is minus 1. Minus 1 times minus 1 is plus 1. So this becomes minus 1 plus 1 is 0i. Then minus 1 plus 1 minus 0j. Minus 1 plus 1 plus 0k, which is equal to 0. So you see that vector p cross vector q is equal to 0, which is also equal to vector q cross vector p. And therefore, this implies that vector p cross vector q is equal to vector q cross vector p.